My name is Bertrand Asnier. I'm the airline data leader at Steria. As part of my job, I work with my AI colleagues to provide data architecture and data capability to support the AI project. Steria is one of the top 5 European services company, and we invest a lot in AI and data projects. And we are recognized by analysts as a leader in this domain. Today, I would like to speak about how to deploy AI projects at scale in the industry, and with a focus on the aerospace and defense domain, which is my main domain. Most of our customers would like to deploy projects on the supply chain, on the manufacturing system, and they would like to exchange data end-to-end in a secure, real-time, trustable, and sustainable way in order to build what we call the data foundation. That means including data governance, providing data connectivity, and all what they need in order to provide real-time monitoring and in order to be able also to provide prescription and prediction powered by AI, and also to deploy advanced automation system. There's a lot of interesting use cases that can be deployed for this kind of industry. Of course, like planning optimization, stock optimization, risk analysis, with simulation of, for example, of the risk you have detected. And there's a lot of possible use case. And generally, we deploy some virtual assistant, for example, powered by LLM. What we call decision support. It could be a simple KPI or an application that displays some prediction of your AI system. And of course, advanced automation or digital twin, where you can simulate any kind of stuff you want to simulate on your supply chain. So this is what our customer expect on a supply chain and logistic, but the reality is that that's not so easy. If we have a look at what Forbes says in early 2024, is that most of proof of concept pilot will never move in production. And I would like today to focus on some root cause of that. Why it's so difficult to deploy this solution at scale on a manufacturing landscape, for example. The first one is that often there's a lack of industrialization. You know that for IA system, you need a lot of data, a lot of quality data. And in a complex industrial landscape, it's often very hard to collect the data. And even more, if you want real-time data, it's even more complex. And because of the complexity of your supply chain. There's also another topic that it's specific to AI system, as that's how can you certify, how can you test it? Because, you know, for example, for generative artificial intelligence, there is a lack of reproducibility of the system. So how can you test it? And if you're on a safety or if you need to certify your system, how can you trust and can demonstrate that the system is compliant with the regulation, for example? That's why we invest a lot in 3 topics, not only this one, but this is a major one. The first one is how to provide to our customer industrialization data platform with ready-to-use library or architecture pattern in order to ease the deployment for this project. Another topic, it's what we call trustworthy IA and data compliance. You know, in Europe, we have a lot of regulation regarding data, for example, the GDPR or AI Act, In aeronautic, we have to comply with export controls regulation. We have a safety certification and so on. So how can we use this kind of technology and demonstrate that the output of the IA is compliant with the regulation, for example? And the last one, if you are using already LLM or this kind of technology, you know that you need a lot of infrastructure to be able to run this solution. And if you want to deploy at scale, there is some cost issue you have to manage. So there's a question of optimization, and it's also close to the question of sustainability, as you have to reduce your infrastructure and the usage of your infrastructure. So I would like to focus on how to industrialize. Of course, most of our customers now have a kind of data science lab, often on the cloud, with the capability to test a new technology and make POC or proof of value or whatever. But they often struggle to move that in the production landscape, and that's generally the major issue. So if you want really to deploy your project, of course, you will need, first of all, a lot of data with historical data, and also the capability to have near real-time data in order to react in real time with if we detect any problem and you want to notify your user, for example. So to do that, you need, of course, a data layer in order to exchange data from your engineering, from your manufacturing, from everyone on the company. And you may need also process or agent orchestration because generally this kind of project is not only a single compute system. You have to communicate with different business applications, and you may need to some process orchestration. And of course, you need also a full DevSecOps stack to develop, test, deploy. And if you want to test, you want to be as close as possible as your industrial reality, you need to monitor your system, for example, to avoid model drift, to provide trust metrics, to demonstrate that your AI output is compliant with regulation, for example. So you need all this stuff to be able to deploy, manage, and operate your application. So what is the classic approach that we can define at our customer? Generally, they have their IT landscape, and they have built a data lake with a daily extract of the data, and often on the cloud, and they made some experiments with this kind of solution. It's okay if you don't need real-time data, but in a just-in-time business, users expect real-time analysis. So this is the first issue they have to manage. And there's another problem is that you will often have a very complex supply chain, IT spread on many sites, and it's very difficult to connect everything. And if, for example, you want to test your AI engine on the cloud and later want to deploy it on you close to your machine, close to your manufacturing system, you have not the same environment, and it's very hard to test and to ensure that it will run the same way that you have on the cloud. So there are a lot of difficulties to manage with this kind of architecture. So why EDA architecture could be an enabler or could fasten your AI experimentation or deployment? That's, in fact, if you imagine that you have already deployed a full event-driven architecture, that you will see that you have already a lot of capability that you need for your project. Of course, it's easier to collect your data in near real time, to store all the events to use it as an input to train your AI models, And also, you are close to the reality of your production. I mean, if you want to test your model on the cloud, you can consume all the events that are already available without any impact on your factory system, but very close to the reality of your factory. That's quite different with the data lake, for example. You can monitor, you can orchestrate, and you can even run external engine, for example, OpenAI or AI, sorry, or so on. You can notify your user. You can send the output of your AI to the business application. So you have a lot of capability that are ready to use, and that will ease the deployment of your project. Of course, if your project is really critical, you may need to deploy it close to your factory, because maybe your factory is not in a big city with a good quality network. So you may prefer to deploy it on a factory. But in this case, when you test on the cloud, you have the same event with the same timeline, I would say, and that it's very close, and it's easy to have a test environment in the cloud and deploy it when it's ready on your factory without a big gap on the way of working. And for example, to have a concrete example, this is a project I have done started in 2018. So it's not it's an old project now running for years. It was for a satellite manufacturer in order to monitor the entire life cycle of satellite from design, test bench, on ground, launch, and in operation. So the application has been fully designed using event broker to collect in real time data from various systems and be able to process in near real time the data in order to first to monitor, to detect any issue on the satellite, and to also to collect all historical data for code analysis, and for example to deeper analyze any issue on the system. Something we have done also is to collect all what we call the business event. The business event is it's all information that can describe behaviors of the system. For example, there is a customer that raised a complaint because the satellite don't work exactly as you want. But we can have also the solar meteo. If there is a solar eclipse, for example, it can explain why there is a low power on the solar panel, and so on. So we collect a lot of information that at first was designed to give information to the support team, but we find that this event can really be useful to explain what we call the technical events, but all the measures, the telemetries from the satellite or any other technical data. And this is another really advantage of event-based architecture. That's now we are thinking events and not in batch. That means that we can have a lot of technical information, business events that will more or less describe the history, the biography of your system. And this is really what I would say gold data for your AI model to be trained, because you have all the history with a lot of data that explain the behaviors of the system, or that can explain also if there is some trouble or so on, and that can be really useful to detect, for example, to build the predictive maintenance or troubleshooting analysis. Another example, this is a new project we are doing for another company. this company already have a big data lake with a lot of data, and another team that work on Amazon to experiment AI models. And this company would like to have more real-time analysis and be able to exchange data in a easiest way between a different domain, from engineering, manufacturing, customer service, and so on. And what I would like to explain here is that if you have a wonderful, I would say, AI model that deliver a lot of analysis, alone it will not deliver a lot of value, because you need to integrate it in the whole ecosystem. And let's take a simple example. You want to analyze your supplier risk, and you want to provide services around the supplier risk. Of course, you may have, for example, a browser that analyzes the news on the web to detect if you have any risk on this supplier. For example, you detect that there's a fire on the main stock for the supplier, and you may have a risk on your supply chain due to this supplier. So this is the first application that detects the risk. With the second application, you can simulate the risk. So what is the impact on your global metric system if this supplier has a risk? And you can notify in near real time your management, saying that, okay, there is a risk on this part. Maybe it will be not available in the coming weeks. So this is the simulation of the risk. And you can have an application that helps the management to select the best mitigation of this risk. And this so it sends the data to the engineering. For example, the choice is to change this standard part with another. So they change the map, and you can then simulate or calculate the impact and simulate this scenario on your AI model, and send it back to your management to validate that, and then update your manufacturing planning to manage this risk. What I would like to highlight here is that, okay, you have a lot of AI powered analysis, but it takes all its value if it's completely integrated in a global ecosystem. And to conclude, I would like to highlight some point. As I said, if you really want to deploy artificial intelligence at scale, you of course need the data foundation. You need data, you need the way to exchange data, you need data governance, and so on. And the event-driven architecture could really be one of these pillars of the data foundation, especially if you need real-time analysis. As I said, business event plus technical events is really the gold data to train your AI system. And also it can ease all orchestration between your different systems, and as I said, to really bring the value of your AI system. And so it can ease your industrialization by decoupling components and make it reusable later. But of course, there is some but. Event-driven architecture, it's a new way of thinking. It's very different than batch-based architecture. And so it's sometimes hard to find a skilled architect or developer. So you really need to train your developer, and don't let them alone, because there's some tips you need to know. For example, how to manage an error, how to manage data integrity. There's some very specific skills to have. And it's even a new mindset for business users. That means we often have some business that do not trust us when we say that we can make near real-time analysis, and are still in batch mode in the way of thinking, and sometimes hard to onboard them. And of course, it's not a silver bullet for all artificial intelligence projects. It's for this use case, and because we have sometimes some customers that think that they have one solution that can address all the needs, and that's not the case in this case. Okay, thanks for attending this presentation, and now we have time for questions. So thanks.